Yeah. You can at least have there's an alternative.
So this is for the
Yeah.
this here, but some people went pretty late, so I think we probably should go ahead and start up if you're ready. Okay. Good morning. Welcome to, I guess it's week 4. So it's we are moving into our section on bioethics and other aspects of responsible conduct of research. So today's session will be in 2 parts. The first part will be presented by Cari, who's the Assistant Director of the Office of the Institutional Review Board. She'll be discussing really what brought us to the point of having the kind of institutional review and permission for human studies that we have and what the process is like. And I think all of you know that after this week we will sign you up to take turns going to sit in on an IRB session during one of your Wednesday mornings. So the IRB meets, I think, from 9 to roughly noon, and depending on how long the discussion takes. And so there will be 1 or 2 of you each week who will come for the first hour of the session here and then go to for your second hour, and as long as you can stay after that, as long as you're finding it useful and informative experience, to sit in on an IRB session and see how the board really operates and what the discussions are that lead to refinement of people's research protocols so that they really meet the highest standards of acceptable human studies use. And then the second half of today will be presented by Dr. Lisa Schwiebert. I'll introduce her when she gets here, and we'll be talking about the process of responsible conduct of research, which is one of the sort of regulatory approaches we have to make sure that people have training in appropriate ways of conducting scientific design and scientific studies. So I know that Ms. Oliver would be happy for you to ask questions along the way and discuss some of the issues. And if there's, she'll describe some of the history of things that went wrong in research. And you have a very short introduction to this by Dr. Saleh, but we've got more detail here. And there are pretty complicated issues, and if people want to discuss it, I know she'll be ready to talk it through. And so please don't hesitate to ask questions.
So just a quick note about coming to the board meeting. The board meeting started right at 9:30, and we're pretty on time. Sometimes if all the board members are there, the chair will actually start a couple minutes early. You wouldn't necessarily know that. If you can't stay for the whole thing, try to stay for the discussion of the new protocols. That's the first thing. Normally we start with amendments and problem reports and audits. So those can be kind of interesting too. Problem reports are things that may have gone wrong in the study that they've had to report to us. But then the new studies are where the more interesting discussions come, where people are really debating human subjects protections, and it's amazing what can come up. After that is renewals, and that's the second half of the meeting. So if you make it through those and you need to go, I'd skip the renewals. I mean, it can be a little tedious at best. So I'm going to give, let's see. I'm going to just talk briefly about the history of the IRB and human subjects research protections, and tell you a little about what we do and how we are, or how we're made up. Our main goal is to protect human subjects. A lot of people think that we get all involved in the scientific creation of the study and design and all that, and we really don't unless that issue impacts human subjects research. For example, if you don't have enough power, statistical power, in order to solve the question that you are looking at, or at least analyze it, then are you putting people through research needlessly? And so we may ask about statistical power, and it may seem like it's a scientific question when in fact it's really a human subjects protection. Mainly we want to minimize risks. We want to make sure that risks and benefits have a balance to them. It's not that there can't be any risk, but the balance has to be that there has to be some kind of benefit involved with it. We want to make sure that when we select participants for research that we do so equitably. We want to make sure that we're not excluding people needlessly. We're not using participants of convenience rather than allowing other people the opportunity for research. And we want to make sure that informed consent takes place. That, of course, is the cornerstone of human subjects research. We're going to go right back to the beginning. We're going to talk about the concentration camps in Nazi Germany. This is where some really heinous crimes have taken place. This is one example of the high altitude experiments with the Luftwaffe. They wanted to make sure, they wanted to know how they would survive in high altitudes. So they took Dachau prisoners and put them in vacuum chambers. And 40% of them died. They did the same thing if they fell into the Pacific, what would happen? So again, they took prisoners, they placed them in tubs of ice for long term, or fed them ice water, and 300 were used, 30% of them died. The interesting thing about, and they were just those were just honestly the most palatable ones that I could discuss. It's interesting if you ever get a chance to go or be, I don't know if you'll ever have the opportunity, but in my field, this is something that's been an interesting debate through the years. Almost every human subjects research conference I go to, there is some kind of ethics panel that involves this issue. What do we do with data like this? Do we use the data so that these people's heinous deaths didn't happen in vain? Or do we not use the data because of the way it was collected? Because to be honest, if you apply the very scientific high-level definition of experimental design, these were solid experimental designs. So the data that was received was good data. It was horribly collected. So what do we do with it? And it's just been an interesting discussion, and it keeps us on our toes when these discussions, and we keep discussing it, and we just keep discussing it. But it is interesting, to say the least. It's an interesting ethical debate. So we had the Nuremberg trials. The Nuremberg trials, most of you have heard of. 23 defendants, hardly the number that were involved. 20 of them were physicians, 7 were hanged, 9 were sentenced to prison. But But what came out of that was the Nuremberg Code, which basically said research has to be voluntary. We have to minimize benefits. It has to have a benefit. And then this last one I thought was always interesting ever since I've read about this, that what came out of the Nuremberg trials was the concept of preclinical animal studies. So a lot of people don't know that. The Nuremberg Code was a code. Didn't really have any teeth to it. It was an idea of how we should behave, but there were no repercussions as a result of it. I think this is an interesting and very true depiction of that code. So we move on and we start getting into the 50s and 60s, and journalism starts really coming into play in exposing a lot of human subjects research ethical issues. The Jewish Chronic Disease Hospital was at Sloan Kettering, and what they did is they wanted to see, can you catch cancer? Can you cause cancer? So what they wanted to do was give people cancer cells and see, if I give them cancer cells, will they develop cancer? So they used an elderly disabled population. And they told them that it was just a skin test and not to worry about it. They did not collect any informed consent, except on the lie. This is just a skin test. Is it okay if we do it? Sure. Two of the physicians were put on probation for a year. But then, interestingly, one of those went on to become the president of the American Association for Cancer Research. Now, obviously, you can't catch cancer, so there wasn't actually any harm. But had their supposition been correct, there would have been. And they didn't know that at the time. Milgram study is, so we hear a lot about ethical issues in medical research, but it also applies to psychological research. And in the 60s, we got really good at that. So the Milgram study was at Yale University, and probably a lot of you have heard of this, this study, but if you haven't, there was actually a movie made, I think last year or the year before, about this experiment, but it's fascinating reading. Basically what they did is they had, so if you were a participant, you would come in the door. I would be the researcher. I was in a white coat, and I would have you sit down at a panel, and I would ask you to administer increasing shocks to a person in another room, and ask you, I would just tell you, turn the dial up, turn the dial up. So you would control the shocks yourself and press the button to administer them. And as they did, you would hear increasing cries from the other rooms, starting out with yips and ah and oohs, and then screaming, and then crying and begging. And 26 out of the 40 gave maximum shocks, which were implied to be nearly lethal. But definitely the sounds coming from the other room were crazy. The person in the other room was a conspirator on the research, so nothing was actually happening to them. The result of the Milgram study was that when they divulged what was happening, the participants, almost all to a fault, not to a fault, but almost all of them ended up with some pretty heavy-duty lifelong psychological issues, knowing that they were capable of doing these things, and it really messed them up. They sued. I don't remember how successful they were, but to this day, many of them have still seek psychological evaluation for participation in that study. Then Zimbardo came along in 1971. This was at Stanford, and it was supposed to be a 2-week experiment where he would bring people in, he would assign them as prisoner or guard, and then just let them go. They were in the basement of the research facility that they worked out of, and he just kind of randomly assigned them and said, go forth. And he filmed them and he monitored them and he watched them. Almost immediately, within about 24 hours, there started to be a breakdown in the society that they had built. The guards took on the role very heavily, started issuing punishments and segregations, and then the prisoners became withdrawn, angry, hostile. It escalated by 48 hours. It didn't reach violent stage, but it was very aggressive and very oppressive there. It was stopped after 6 days. Somebody finally stopped it. Interestingly, though, and not this last, but the reason it was stopped, during those first 6 days, other investigators and professors and colleagues of Zimbardo came through to see the experiment. They walked through, they saw everything. About 30 to 35 people passed through to see it. It was Zimbardo's girlfriend who actually said, dude, you need to shut this down. So all these researchers thought, isn't this fascinating? It was somebody who wasn't a researcher who saw the ethical issue. Zimbardo testified as an expert witness in prison guard trials at Abu Ghraib. Because this study was so effective, he was able to kind of shed light on what those prison guards, their psychological issues that were going on there. It's a fascinating study too, and you see, and it's been replicated a couple of times, poorly and wrongly, but it's interesting. Obviously, everyone's heard about Tuskegee syphilis experiment exposures. I had heard about it. I knew a little bit about it until I started so I joined this field. And when I really started looking into it, I realized how systemic the attempt was at diluting these people. They did a remarkable job. Originally, it was supposed to just be a life cycle. Let's just watch and see how syphilis progresses through life. There was no treatment for it. So they just wanted to gather data. So initially, the study was well devised and was just trying to gather data on the life cycle of the disease in people who had it. But it started in 1932, and you can see in 1943, penicillin showed up. Penicillin cures. Well, they thought the better of offering them that treatment, and they just kept doing what they were doing. And it wasn't until 1972, so that's 30 years later, that a New York Times article came out to expose it. And what we found during that time is they would just take blood from them and tell them that they implied that those blood tests were treatments, that they were actually treating them. The men involved in this didn't really know what was happening to them. They encouraged the men to continue to have sex with their wives because they wanted to see how it would progress through the family. They utilized an ally within the community, and I forget her name, but it was a nurse, and she was an African-American woman, and she was the kind of liaison into the community. And she knew fully what was going on, but they utilized her in a very meaningful way to continue the deception. This study right here has probably one of the biggest impacts on human subjects research that we can imagine. And yes, the study was terrible, and we learned a lot about how to behave. But what we have, the result of this has been a long-standing and tenacious distrust from poor African Americans of the research community. So we've never really overcome what we did to the community as a researching group. So even to this day, white coat syndrome from the poor African Americans is still there, and it's almost predominantly attributed to this lovely experiment. So after the New York Times article came out in 1974, we got the National Research Act. It was almost in direct response to Tuskegee, and it created this National Commission for the Protection of Human Subjects and of Biomedical and Behavioral Research. So we were acknowledging Zimbardo and all the others. So this commission got together and they went to a hotel, Belmont Hotel, and they wrote the Belmont Report. And it was published in Federal Register in 1979. So it didn't take them 5 years, but I think from the time of the commission to that, it was 5 years. That's how much they thought about it. And I would advise you, it's not long, I would advise you to read it. This was enacted in 1979. We still refer to it every day. And it's, you know, a lot of people talk about the U.S. Constitution as kind of a really short, elegant document that was able to span all these changes in the world and still kind of stand alone without having to be amended a lot. And the Belmont Report is very similar. It's a very elegant report. It really synthesizes things down to basically 3 rules. And within these 3 principles or guidelines, you can pretty much put everything that we deal with even today with genetic research and, you know, more and more issues of confidentiality with the electronic world. These all still fit within these 3 principles of the Belmont Report. So the first one is respect for persons, and then beneficence, and then justice. Those are the 3 principles that came out of the Belmont Report. And respect for persons is where we bring in autonomy. If someone is mentally incapacitated, we can't just go forth without really figuring out how to get consent. It's where legally authorized representatives come in. It's where witness signatures come in. And the Belmont Report in action there is the consent process, informed consent. Beneficence is do no harm. That's a very simple term. Don't be mean. Don't hurt people. That maximize the benefit. So this is the risk-benefit section. And when you bring in risk today that can apply to risks of doing genetic testing and maybe that affecting someone's ability to get health insurance. Do no harm can mean don't gather data that you're not going to hold securely that can then be breached. So the risks and benefits of consent really umbrella over a lot of the issues that we're dealing with even today that they couldn't have foreseen in 1974. And then justice, fairness and distribution. It's the selection of subjects and criteria of enrollment. And a lot of people, a lot of researchers don't really think this through or don't think about it as much as these gentlemen felt we should. And we still try to enforce. So for example, in Birmingham, we have a large Hispanic population. But in order to involve those people in research, we have to speak their language. We have to translate consent documents. We have to have a translator on staff. And a lot of researchers don't have the money to do that or the time to do that or the desire to do that. And these guys are saying, and we're trying to say, is maybe you need to. Are we excluding a large portion of our population in Birmingham because it's too much of a drag for us to do it? So one of the things that the Belmont people said, and even our regulatory bodies today say, is inconvenience is not often a good enough excuse. And so we have to think about those things. We've seen through the years that medical research doesn't involve children or pregnant women, and therefore, when it comes time to treat those people, we are spitballing. We are guessing on what the dose level is for an 8-year-old. We're guessing whether this drug will pass through the milk into a lactating mother. We don't have enough research in these people. And It's because people don't want to use a vulnerable population because, oh gosh, what could happen? But it's a balance we have to start working out, because right now we're guessing at pediatric dose levels and we're guessing at pregnant women dose levels. So we have to start and think about, can we include this group and what is truly the harm? So that's kind of the history and where we are. And it's not like human subjects research ethics issues stopped after the Belmont report. It's not like we all went, oh great, we fixed it. We didn't. There continue to be problems. There continue to be issues. UAB has been embroiled in one for the past 5 years. We were the ones who kind of shed light on an issue of comparative effective studies. So comparative effective studies are when you have two standards of care and you want to know, you want to do a study to find out which one is better. And it has forced our governing body, the OHRP, which is the first one up there, it's forced them to actually look at guidelines as to how we approach that. Prior to that, there had been no real guidelines on how to deal with randomizing somebody into standard of cares. So if some doctors use this and some doctors use that, but now the protocol is driving that decision instead of having it be a physician's decision, there are risks inherent in there. It's taking the decision out of the physician's hands about how you're treated. And so we have to look more closely at that and be more forthcoming about what the risks of each of those arms are. Prior to UAB's support study, a lot of people would say these are standard of care, so there's no harm. But the reason we're comparing them is because we're starting to get indications that maybe this arm is a little faster or better or more or less risky. And so what we know, we need to explain. We need to tell them, yes, these are both standard of care, but research is starting to show that this one's better and you may get this one. So we have to start telling them that. And that's minor. We've had bigger ones. There's been issues in Costa Rica. There's been issues with Native Americans. We just don't seem to always get it. So our governing bodies, OHRP, this is DHHS organization, the FDA, HIPAA, and also we have educational issues. We have the Family Educational Rights and Privacy Act, FERPA. I don't know how many of you have ever heard of it, but it's kind of the HIPAA for education records, your test scores, your grades. The Protection of Pupil Rights Amendment is we can't go in and give really sensitive surveys to minors, which researchers love to do. We want to know, are they having sex, are they doing drugs, what are they doing, what are they doing? We can't do that without parental permission. And then specific studies may have additional requirements because they are DoD funded or Department of Justice funded, and they all have kind of similar little quirks of their own. So those are our regulatory bodies that we have to keep up with. They're not always concordant with each other, so some of them call things slightly different or have slightly different rules, and it's not always clear who wins. There's been an endeavor for us to try to kind of harmonize everything, but as with any organization, you want to hold tight to your own decisions, and so it's not been 100% successful, sadly. So IRB, we are a code of federal regulations, which means we're a law. A lot of people don't realize that. We're a law. We have, there's a book about this thick of all of our regulations talking about how we conduct research, how we analyze, how we approve, what we can do, what the makeup needs to be. So we're not just here to annoy you, we're here because we're mandated to be here. An IRB has to have at least 5 members. Ours has probably 20. It has to have at least 1 scientist. We're science heavy. It has to have at least 1 non-science scientist. We tend to have 2 at least at the board. At each board, we have 2 boards. So to keep up with our volume, we meet once a week and every Wednesday, and we alternate board 1, board 2, board 1, board 2. And sometimes they cross-pollinate. There's about 40 people who are on our register, and then probably another 20 to 25 who serve as alternates when people can't make it. We have to have a community member that isn't associated with the institution at all, and we have to have a prisoner advocate. It says in some circumstances, but for us, we have to have. So we have 2 people who serve that so that they can be at each board. The reason for that is prisoners are a vulnerable population, and they have their own set of regulations. And we need to make sure that because they're so open to coercion, that we need to make sure that the research that's being done on a prisoner population doesn't cross that line. And we need somebody close to that, that population. The non-scientists and
what kind of person is the prisoner?
mostly people who work directly with them in a social service area method. Bill Devane is one of ours, and he works directly with the population in seeking services as they release and helping design programs for prisons. So he's very familiar.
I've been a prisoner at some point.
No, but I know that there are some boards that have utilized people who are former prisoners. They use them both as a prisoner advocate and a community member not associated with the institution. Many of our community members not associated with the institution represent clergy. We have a rabbi, we have a Methodist minister, and I think this is 2 we have, because in the South we feel like we have an obligation to kind of look at things that way, because that's how our participants look. We're a much more religious-oriented society than some other places in the country. So we have community members. Most of our community members are clergy of some kind. Our non-scientists are these people right here. They represent the participants. So just as I was saying in the Zimbardo study, where all these researchers came through and went, wow, that's really cool, and it took his girlfriend to shut it down, these guys represent the girlfriend. These are the people who are asking it from their perspective. They're looking at the consent form saying, I wouldn't understand at all what's going on. When all the scientists are like, oh, this is a great study and this makes perfect sense because it computes to them, these people represent the voice of the participant. It's very important that they're there and that they feel empowered to speak up. There are some IRBs where the scientists are so passionate that they squash the voice of these non-scientists and community members. And we take really great pride in the fact that our community members feel very empowered to speak.
So do you rotate or change those people? Because after a while they
learn.
They learn.
And yes, we do. So typically they'll serve. I mean, we don't boot them out, but we'll bring in other people. We'll bring in new people. Typically they're here about 3 to 5 years until they start getting numb to it all and realize that. When they start talking about circulatory systems and things like that, then we know. Yes.
How do they get recruited? Is it
word of mouth to some extent? It's hard to find the clergy people because this is a commitment in time. The board meetings themselves take anywhere from they'll last anywhere from 9:30 to 11:30. But we've had them go till 2. And you have to prepare for the meeting. So we take our protocols and we divvy and, we shuffle them out. And then they've got to go home and they've got to read them top to bottom, just like we would, just, what's involved with creating them. So they have to read them, they have to become familiar with them, they have to take notes on them, and then they have to be prepared to discuss them. So it's no small commitment of time. We pay our board members. Many IRBs across the country can't afford to do that, so we're fortunate that we can attract people and keep people for a while. In some organizations, membership on the IRB is mandatory and assigned by a chair throughout the organization, and then time will be given for that endeavor. So people manage this a lot of different ways. We're just fortunate that we're a large enough institution that we can afford to compensate them, because they do. It's not a small commitment. It's probably, maybe 10 hours a week. And many of these people have full-time jobs. So we do have people who are retired that come in and do these things. So that's how we do it. It's interesting.
Tell us how much you compensate them, I'm curious.
I don't know. I don't know the number. It has to be a certain amount because many of them are retirees and they can't make so much. And they don't all serve every week. So we have enough members that we can kind of mix it up and have a variety of people coming to the board. We try to have people on each board that represent very important and high-risk studies. So we want to make sure we have a cardiologist and a pediatric oncologist, and we want to make sure we have some of those scientists represented. But we also have some social sciences represented, because even though they don't come very often, when they do, we want to look at them very, very carefully. It's kind of a science in itself on how to create the right mixture of people in a board so that you're really capturing the risks and the benefits. And then one of the things that's written into the code is if we don't have the expertise on the board, we can actually go and get someone who will serve as a one-time board member as a consultant for that protocol. So when new technology arises, things that we haven't really experienced before and we're not sure what the ramifications of them are, when we started doing gene transfer and when we started doing gene splicing, we brought in fact, for the CRISPR technology, we actually brought somebody in from outside of UAB because everybody here at UAB was involved in the research we were actually evaluating, and we didn't feel so. We sought truly outside expertise on just someone saying, how does this look? Because we were unfamiliar with that technology. Gene splicing was not something we had dealt with at that point. So it's interesting. And when you come, you'll be able to tell pretty quickly who the community people are, who the scientists are, and know what they are. But it's interesting. I find it very fascinating. All right, so the Belmont are those principles we talked about. And the OHRP and the FDA, those give us the regulations that kind of utilize those. The IRB takes those regulations and we apply them to make a decision, and then the investigators go and enact the science. So we're all intertwined and it all works fairly elegantly together. I know I've used that term a couple of times, but I'm pretty impressed with the number of groups that are involved in getting research going, that it happens at all, and then I see how it all works together, and it seems to be pretty good. So the IRB, what can they do? They get to approve research, which they do all the time. They get to require modifications. This is when we say we want to ask for more information. So we can require them, we can ask for them, we can suggest them, all mixed up in there. We can disapprove research. I've been here 9 years. We've done it twice. This is research where we've gotten it, we've discussed it, and we've said no. Not at all. It's rare. Now, there's been research that we have heavily disagreed with, and we have required heavy modifications. We have met with investigators and their bosses and sat down to say, I understand what your research question is, but here's what you can't do. And so what can we think of? And so we've kind of, guided that process a little bit. But it was ultimately approved after a lot of tweaking. We have to review every year because new laws come out. Changes get made to the protocols, changes get made to our regulations. So we review every year. We also want to review every year to look at trends in that particular research. So we want to know, are we seeing a trend towards the experimental arm being highly effective? So let's say you have a study where you are putting people, randomizing people into a control and into an investigational arm, and within 3 years you're seeing absolute clear improvement in people in the experimental arm. And we need to discuss how ethical it is for us to continue with the control arm. Is it ethical, knowing what we're seeing, to continue to deny people that opportunity? And it kind of works the opposite too. So if we start seeing trends that say this is not only not helping, but there are side effects, and these side effects are not, so we might look on the other side. We might look at problem reports and look at the trends of those. Are we seeing more and more people who are having an unexpected but drug-related response of diarrhea or flu or something like that? Then we didn't know that was a potential, and are we reporting it right? And are we making sure they're aware of it? Have there been new findings in the research field that have other people done research and completed their research that kind of makes your research moot? So we have to look at all of those things on an annual basis, and in some cases more often. In some cases we do quarterly. If it's gene transfer, if it's high risk or higher risk, we may want them to come back quarterly or every 6 months so that we can look at it a little more closely. And we audit research, so we go out, we audit the consent process, we look at the regulatory records, we make sure that they're doing everything the way they said they were going to do to some extent, and we work with Office of Compliance with that. So if we see issues that are systemic or ongoing, we may work with the Office of Research Compliance as well. And of course, we can suspend and terminate human subjects research, and that's happened here at UAB. People who have played too loosey-goosey with the rules for a long time, and despite efforts by us and compliance and their management to get them to respect the regulations, they haven't. And so we have barred them from doing research, which, as you all know, greatly hinders your ability to grow as an investigator or as an employee. So we have that power. We need to make sure, I'm going to go over this, I think I've gone over all of that. I'm not going to go over that again. So a couple of terms that I want to make sure we cover before we leave, and I want to make sure there's enough time for questions if there are any, is there's a definition for research, capital R. It's a systematic investigation designed to develop or contribute to generalizable knowledge. Well, in their infinite wisdom, no one told us what generalizable knowledge was, so this has caused a problem through forever and for always will. But it doesn't always just mean publishing. So a lot of people think if you publish, it's research, and that's not always true. Most research is published, but not all that is published is research. So it's generalizable knowledge really means, is the intent of your research to increase the knowledge in the field on this issue? Or is it alternatively the purpose of your research to solve a problem in your area, in your clinic, in your hospital, in your school? Are you just seeking knowledge for your own edification? But if you're seeking knowledge if you are designing your research to then be transferable to other situations, then you're likely doing research. And it has to be systemic and in nature. So that's why case reports are not considered research. A case report of 3 or less are not considered research because it's not systemic in nature. It's likely not going to generalize knowledge. It will add some information, but a case report or a case series of 3 or less is really not going to meet this definition. Once we've decided it's research, then we have to ask, is it human subjects research? So now we have a definition of human subjects. It has a few more parts to it. Living individual. So deceased individuals are not considered human subjects. HIPAA views that differently. But in research terms, if they're deceased, they're not human subjects. So a living individual about whom, so we're going to do something to this living individual. We're either going to interact or intervene. So I'm either going to talk to you to give you a survey, I'm going to poke you, I'm going to take blood, I'm going to give you a drug, I'm going to interact or intervene, or I'm going to obtain private identifiable information. So about a living individual about whom. So I can't count how many times I get protocols where the data they're going to collect is really hospital level data, number of falls, incidents of TB, and that's not a living individual about whom. So even though it kind of has that feel of human subjects, it's not really. Or it's identifiable private information. So I could collect data on every one of you and ask you what your hair color is, what your age, your sex. I could ask you whether you smoke or not. But if I don't obtain anything that's identifiable about you through a survey, let's say, then I may not, that may not be identifiable. It is an interaction or intervention, so you're still a human subject, but it's not necessarily identifiable. So there's a lot of data you can collect that doesn't qualify as identifiable. And if there's not an interaction or intervention in doing so, say you're getting data from the Census Bureau or you're getting data from another colleague who's already conducted research and has de-identified it, may not make the definition of human subjects. So those are really 2 huge definitions that we have to apply to every study that comes, because some people leapfrog over those definitions and apply to the IRB, and we have to go back and go, but is this really research or is this just quality improvement? Or if it is research, is this really human subjects research? So we kind of start with those 2 questions every day.
Quick question.
Yes.
So from a clinical application, there are data that are entered into databases for, prospectively entered data that's well monitored and very good data. Code data, for instance, for some pediatric cohorts, et cetera. Can we then retrospectively look at that, and that is not considered human subjects because they're not identifiable and you don't even...
It's entered for clinical purposes?
It's entered for the most part, quality improvement purposes, but you can ask specific questions using the data and obtain meaningful information to answer that question.
You can, and the answer is yes, there's a little qualification to it. There's a couple of qualifications to it. One is the burden's on you to prove to us that that truly is de-identified. You have to be careful on who you put on your research because the people who enter that data in there can't be part of your research team. Also, if you are collecting data for clinical purposes or for quality improvement purposes, but it becomes a continual choice of researchers to mine, we're going to want you to submit an application to cover the entry and maintenance of that data set. Because for registry data, for data that is used often for research purposes, we want to make sure confidentiality is maintained. So even though that it may have started out for non-research purposes, word got out that this is a great data set, we want to start using it a lot, we need to maybe intervene and make sure we're understanding how that data is collected, how it's being stored, what the confidentiality measures are in place for that, if it's going to be a mining set. So, you know, we know what that is for our electronic medical records. We're comfortable with that. We don't have an IRB for electronic medical records. But every lab in this university has that freezer that is full of crap that no one ever got rid of. And people just keep going to it. And we don't know where it came from. And we don't know whether people agreed to let you do the things you're about to do. And we don't know how it's being stored and how it's labeled and, you know, where could a breach occur. And so every time we hear that, oh, well, you know, he just never throws away flu samples, so we're using that. Like, never? How many samples are in there? And did you tell your people you were going to just hold that ad nauseum? Because they get to kind of say yes or no sometimes. And that's just that bleeding over from clinical hoarding to research is a problem. You know, it's just a problem. And people don't, and you don't recognize when you started merging over. It's just a meandering over, and all of a sudden it's this major research source that no one knows how it got there, no one knows how it's stored, managed, or maintained. So we try to kind of keep aware of those. One-time shots we get, hey, there's this great thing someone did, I want to grab it. But when it becomes continual, we want people to kind of recognize, you know, maybe we should maybe formalize this a little bit so that we know what we're doing. So that's kind of where I am. And just because it doesn't meet the definition of human subjects research doesn't mean you don't have to apply the IRB. It's just a really small application. It's like 2 pages, and there's only one question that actually matters, and that's telling us what the purpose of your study is, where the data or specimens are coming from, and assurances from the source that they are truly de-identified. We don't have to see them. You don't have to prove it to us that way. But you can't say, trust me, they're de-identified. The source has to say, I'm giving these to you, and they're completely de-identified. But it's a small application. It doesn't take much time. I have 8 minutes, and I'm not going to go any further because this is just kind of more of the same. So I just want to make sure if anybody has any questions or if you guys have time to stretch your legs before the next speaker.
My question is, I have done some work with the identified data. I generally work with the secondary data anyhow. And some of them are hospital level. You have started maintaining a list of data sets that do not require non-human subject.
That was my idea.
That was your idea?
Yes.
Oh, that's an awesome idea, by the way. Thank you very much for that. Because, I mean, the process is like all the time you have to go through, it kind of creates efficiency on your side and on our side. Who determines that list? Obviously, who's keeping up with?
Me.
You. So if we have a...
So there's a nomination form. There's a nomination form. So if you want to nominate I don't create the list, I maintain the list. I created the initial list just on things that I knew were frequently brought to the table as data sets that were qualifying for not human subjects. But when I created the first list and it went out, and then with that came a nomination form. So if you have a data set that you know you're going to tap over and over and over again, or your students are going to tap over and over and over again, then you can nominate it. So the nomination form makes you do the legwork. It makes you go and find the section on the website that attests to the anonymity of it. It makes you tell us the specific data set you're looking at. Because if you go to ISPCR or if you go to census.gov, there's 4 million data sets on there, and not all of them qualify. Most publicly available data sets have a public set and a restricted set. And the restricted set doesn't qualify for non-human subjects because it tends to have things like dates and zip codes in it, which are identifiers. So we have to know specifically what it is, but nominate away, and then I go and I verify it, and then we add it, and then no longer do you have to apply to the IRB for that.
Thank you.
Okay. Yes.
And this may be a little bit more specific, and I just have a question about paying human subjects in that I had a study previously where we paid the controls, but then didn't pay the experimental subjects, or the plan was not to, because it may introduce some sort of bias in that the diagnosis was made subjectively. So if you pay them, maybe they report symptoms more or anything like that. And actually, the IRB came back to me and asked me why I was not paying the experimental groups. So, I guess my question is, if y'all allow that up front, should, we just go ahead and do that, and then on the back end, maybe put something in there about, we're not sure if paying them cause some sort of bias, or can you speak to paying, experimental versus control at all?
It's a pro and con, right? So there are issues for both sides. A lot of times when the IRB asks questions, we're really giving you an opportunity to justify what you said. So it would have been perfectly reasonable for you to say, we really don't want to, and here's why. Maybe that wasn't clear to us when we first reviewed it. People seem to be reluctant to do that with the IRB. There's this sense of, they say it, we ask how high. And that's really not, I get people all the time where the board will have a question and then the investigator or coordinator will call me and say, but we can't do that. And we're doing da-da-da-da. I said, well, then say that. You're allowed to say that.
Right.
So, if you have a strong feeling as to why your particular study paying those, like you said, subjective diagnosis, which I'm not fully sure I understand, but you do. And so you could have probably made a justification for it. In general, though, we understand that controls are harder to get, but there is a fairness that we want to make sure is there with payment. We want to make sure that we have a lot of payment discussions. When children are involved and we're paying the parents, that can get really dicey, especially if you're dealing with a population where money is not something that they're familiar with or as familiar with. So are you paying a parent to put a child through something they don't want to be in? Even though we have a cent and the child can say no, it's a weird thing. So we want to look at those very carefully. We want to look at prorating payments. For instance, you can't make payment contingent on completion of the research. So if you have long-term research, you're going to have to prorate those payments and pay people as they participate. So we have a lot of payment discussions, and we know that there's a lot of really weird ethical decisions that have to be made. So next time that comes up, at least try, write back and give us your justification. It's never advisable to be defensive when you do that because nobody responds well to that. But our board, I know, they often just want to hear a sound justification. I can't count how many times something has come back and someone has said no and here's why, and they went, oh, that makes sense. And then off we go. But now we've done it. We've done our due diligence. You've justified it. We have it on paper. Any other questions? Cool. Okay, so as you guys sign up, I want you to know we are moving to we are in the penthouse. So when you go in, you'll take the elevator up to the 13th floor, and you have to get off and either take the stairs up one more floor or take this little tiny elevator that's across the hall up one more. And that elevator's a little dicey, I'm going to tell you.
Do you mind reminding us, I'm sorry, which building this is?
It's in the administration building. It's just cat a corner from here. It's right over there. It's the tall red brick building right there in the Compass Bank, and not Compass Bank, BBVA. It's always the compass bang for. So we're in the penthouse now, and we don't have enough chairs, so only 2. So in the past, we've allowed sometimes for 3, or if you've missed your meeting and had a conflict, you've just gone in as the 3rd person. So now, if you miss your meeting and there's a conflict, you're going to have to find somebody to switch. You really need to think about it. We cannot have more than 2. There's just not enough room. No cell phones out. Some of you are on call, I know, and so you may need to keep something kind of surreptitiously down, but do not be surfing on your phone. It will not go over well with our board member. You will be introduced when you first get there, and he'll want to know where you're from. He'll want to know where you're from here at UAB, and our president, who is Dr. Ferdinand Ertaler, who's from Switzerland, who loves all things international, will want to know if you are from another country. He'll want you to tell us that. So he'll introduce you and get a little talk out of the way, and then just listen and try not to fall asleep. All I can ask. Okay, cool.
Thanks very much. Okay, so you have 3 minutes for everybody to touch their legs.
I'm not sure that she can hold my most up-to-date slides.
Okay. Thanks very much.
Oh. It helps me get the kids off the school. Take them out to the airport.
Oh,
Holy
crap.
I
knew
knew
it
it
was
going. I'm so happy. You made my day.
yeah, I've got 4 names in it.
Oh, me. And thank you, too, for participating in grant writing. March.
I'm just going to give you a heads up. It is warm.
It is really warm in here. We can crack the door.
Otherwise, you're going to find me on the floor.
So, in the show. And in here. How are you?
Trying to make contact with that one to talk over the
Oh, yeah.
Just my brother started with figuring out if there is an alternative to sit down with it. So I'm
Gotcha.
just give something
I
for us
do.
to talk over
I do.
what exactly how people come feedback that all
Sure.
time would make a difference for who would be able to show up for.
You know, lunch always works best.
Yeah. So, because we have to, if we can stroke it, people
Yeah.
show up.
Yeah. Yep.
Okay. So, and I think we're probably towards the end, since we were strong.
You know, we went ahead and put in a deposit. No worries there.
Yeah.
So if you were to have the event, so we are having ours on that Tuesday. So you're thinking of having yours later in the day or the next day?
Yeah, so that'll,
I mean, we could push it for you. And, you know, I don't know when we go to 2. That's the thing.
yeah.
But it would be a different.
It would have to be around. So this is a question of whether it's
Yeah. This is right out.
so
Yeah. Let's do it.
what did you
Well,
That's one. It's good to have a lot to do, but it actually, kids just really
there's some overlap.
So, you're
Oh, the Jeremy Simpson. You know, it has, you know, sort of that, but I find that it has allowed me to allowed great. But, you know, I think I've talked about this before. The beauty of it for me is rather than taking a piece of it, we get to live it all together. And they're such friends that not real elementary. Like the intersection of really just be honest because you sign it personally. So that we've had great comments. I think people are excited.
Yeah.
It doesn't. There are other personal issues. Something.
She spent a lot of time in school.
Yeah.
I know there's this doesn't really been announced yet, I guess, but the state of it's good. But
Yeah.
People a year just from around the state to try to figure out whether there will be value as their and so they're going to actually do some kind of so anyway, she's the this is associated
Yeah, so she's
yeah, there's actually, so David, I tried to set up.
Did you? Do you know Brian Wallace?
We have to do that ahead of time. I did not. Okay, we'll go ahead and get started. Our next presenter is Lisa Schwiebert. Dr. Schwiebert is the Associate Dean for, actually I never keep up with that every few months, but for Graduate and Postdoctoral Affairs at UNSCOL. And she's also the institutional representative for responsible clinical research training. She's a physiologist and immunologist who has made her career studying mechanisms underlying asthma, but she's also very involved in career development issues, and she's going to discuss today. So she's a great resource, and it's very accessible.
Well, thank you all. Hopefully I'll be able to keep you awake for another hour or so. It helps that we have the air going. And I was kind of drifting off that So, and let me just say too, I know you picked up a copy of the slides, and of course, between when I sent them to Jean and this morning, trying to get my kids out the door and my husband off to the airport, I kind of redid them a little bit. So you'll see a little bit of changes, but not too many. And let me say too right now that there are a bunch of embedded links that I would love for you to have. So if you're interested, I can certainly email the revised one to Jean and have her certainly send them out. Okay. So all things research conduct. We're going to talk from a very 30,000-foot bird's eye level of all things RCR at an hour's time. Has anyone taken the 717, GRD 717 course? Great, so this will not be a huge repeat with some of the information. So a lot of what we do here at UAB is driven by the NIH. And the NIH does have, if you will, a research conduct office. It's called the Office of Research Integrity, the ORI. And they have generally laid out a series of 9 areas that everyone should be up to date on with regard to what misconduct means in these various areas. I wonder if this pointer works.
Oh, you can't actually
Okay, no.
see it on the TV, so you have to use the arrow if you want to point it.
Okay. Well, I think you can see the bullet list here. We're not going to dive into each of these areas. The course that I mentioned, the GRD 717, is a research ethics course that trainees must take, graduate students, postdoctoral fellows, certainly involved in basic clinical science, track through that course. And we do touch upon each of these areas. In the long day, Dr. Chaplin has been one of our facilitators. We have Saturday workshops that start at 9 and they go all the way to 5. But we work through all of these areas in a very intersectional way because many of them overlap. So we're not going to touch on each of these areas this morning, but I wanted you to be aware, certainly, that this is how the ORI definitely classifies areas for potential misconduct. So this thread, if you will, at UAB is held by compliance. You heard a little bit from Cari this morning about how she integrates some of her work or issues into Office of Compliance. And they are really the keepers, if you will, together with the Vice President for Research, of misconduct analysis, if you will, research misconduct training, that's where my hat lives. And so I just, again, wanted you to be aware of this office, and again, of the links that are embedded within the web page. So what is scientific research? So the ORI definition and UAB's definition are very simple. Fabrication, falsification, and plagiarism in proposing, performing, or reviewing research or reporting research results. So that's known as FFP, fabrication, falsification, plagiarism. So the UAB definition is very similar, but it also includes a statement of other practices that seriously deviate from those that are commonly accepted by the scientific community. What do you think that means? What would be a practice, say, for your area that is a standard that if someone doesn't adhere to, could be considered misconduct? Think about the speaker just before me. What if someone were to try and publish results of a study where no IRB approval had been obtained? Is that misconduct? Does that deviate from the norm? It wouldn't be published. It would be kicked back in a hurry from a journal. And that's just one example, certainly. So a little more depth to these definitions here from the NIH. So finding research misconduct requires that, again, a significant departure, that misconduct be committed intentionally, knowingly, or recklessly, and that the allegation be proven by a preponderance of the evidence. So similarly to for UAB. My goal here is to show you that we are very much in line with the NIH and adhere really to their standards. So certainly bringing malicious charges against another individual could be considered as as misconduct, as well as interference or retaliation. Well, let me go back to perhaps another deviation, if you will, from the norm. So some of your questions for Cari were about collecting data, perhaps analyzing that data. Are any of you involved in studies now where you're collecting data? And are you the PI or is your mentor the PI?
I'm the PI.
You're the PI. Do you have anyone working with you to help collect these data?
Yes.
How often do you check that data?
Well, it's imaging data,
Uh-huh.
so, I mean, you know, as I process it, I check it, but, you know.
So data management is a huge topic in misconduct. If you can't get your hands on that raw data and you go and try to publish it, that could be considered crime. I mean, basic science and lab science, probably, you know, a little more in line with sort of that hard physical data. My trainees, I'll just give you a personal example, I had a wonderful student, turned out not so wonderful, nice guy, but he never kept the raw data in the notebook. I was a very green assistant professor, all excited to have a student. Went to look at the data, I didn't look at it as closely or as often as I should. It wasn't there. We lost a year's worth of money, time, certainly, and ultimately he didn't graduate with his PhD because he did not maintain the data. And it was my responsibility to make sure it was there. But had I tried to publish without that data, that could have been a problem. So again, that's a deviation from the norm. Just a heads up to say, always check that data, keep your eyes on it, and look at that raw data whenever you can. So fabrication. We're going to take each of these, fabrication, falsification, and plagiarism now, one by one. So I should have said at the outset that a lot of these slides were developed by my predecessors, Drs. Charlie Prince and Jeff Engler, and they have allowed me to tweak them and use them with their permission. And Jeff Engler, you know, he loved it. He loves Dilbert. So I show this picture of him. And, you know, I have to say, I've watched too much CNN. With these alternative facts, perhaps? I don't know. Go figure. Okay. The example. I didn't have any accurate numbers, so I just made this one up. Studies have shown that accurate numbers aren't any more useful than the ones you make up. So how many studies show that, he's asked? 87. So fabrication. So fabrication is making up data, yes, in this case? So this is a classic example of a Japanese scientist who literally made up data for 172 papers. Holy cow. Wow, right? I think it's over perhaps a 19-year period or sort of 19 years, yes. 172 papers. It's like someone just wrote a novel. Oh my goodness. Here's another, little more close to home, and I show this one as a classic example. This is the first scientist who was brought up on charges and actually received jail time for his fraudulent behavior. He was at UVM, and this was now well over 10 years ago, at their medical school, and fabricated research data on a variety of topics. But through that, he fraudulently obtained an arrangement, a lot of it. Not cool. He did end up serving, I believe it was a year and a day in prison. That was his sentence. Guess what he's doing now?
He's an IRB director.
Worse. So this was in Burlington, Vermont, my part of the country. He's actually just over the border in Montreal as a college counselor. I had 2 kids in high school, and that hurts me to know that. But all that to say that ORI does look very closely. And it was actually in part one of these cases that really drove the development of that office. But there can be jail time, which is great. So falsification. ORI and UAB's definition, manipulating research materials, equipment, and so forth. Changing or omitting results. So what's the difference then between fabrication and falsification. What do you think?
Fabrication generates something from nowhere.
Okay, so you're making up something new.
Yeah.
So what's falsification?
You kind of tweak things and falsify.
To make it look pretty.
Say again?
To make it look nice.
Right, so fabrication is making up data. Falsification is selecting data. Well, that's an outlier. I can prove that that's an outlier. People take great pains to just fit it right to that hypothesis. So this is probably a little more easy to slip into sometimes if you're working really hard to prove that hypothesis. When in reality, we should be trying to disprove our hypothesis, to be really rigorous in doing that. This is a little more slippery. So I'm going to talk about image fraud, and this is probably one of the easiest places to find falsifications. You're trying to tweak, make it look pretty, and so forth. So journals find fakery in many images. I used to be an associate editor for one of the American Journal of Physiology journals, and it was about at that time that a lot of the technology and the software platforms were becoming sophisticated to analyze images. And pretty soon you started seeing really interesting things kind of popping out of these images that had been somewhat manipulated. It may have been just trying to cut off a lane to get everything into one figure, but in doing so, either it wasn't justified or rationalized or well-defined as to what was going on. So journals are really all over now looking at images. So again, this is a little dated, but even back 10 years ago, over 40% involved accusations of image fraud. And that's only been increasing. Journals want to see the dirt. They don't want to see something picture perfect pretty. They want to know, they were scientists in the lab at one time. They know things don't fall out beautifully, or should they? So they want to see the dirt. So here's a few examples from an earlier publication. So I think you can see, as it says there on A, the rightmost bands were clearly copied over and over. A different in B, an exercise in excessive contrast. I don't know if you can see the split here where it was cut. But there are many different ways that images are manipulated, copied, cut and pasted, merged together. It will be found. So here's an example. Cells, various different types of treatment, with or without curcumin. What do you see? It's a leading question. Yes, something is wrong here. Something has been falsified. Are all of these independent, different images?
Yeah.
Say again?
Second row, the first one, the same.
Yeah, the 4% is the tip-off, isn't it? Yeah, they're the same image. Stop. So, who typically identifies the manipulation? I talked about journal editors. But sometimes those that you ask to review will find it. Post-publication retraction watch. Has anyone followed that? Never want to be on retraction watch. Or this Claire Francis. I don't really know who Claire Francis is. But again, it's a similar type of web platform where people are outed, if you will, or thought to be fraudulent. Never want to be there. So dealing with image fraud, again, I'm not going to belabor this, but what I do want to make sure that you're aware of, and again, why I want you to have these links, is that part of my task, part of my RCR hat, is not only for training, but also to make sure that here at UAB, everyone has access to platforms and software and approaches to really protect themselves from not only image fraud, but plagiarism that we'll talk about in a minute. So there is a wonderful explanation of droplets. I think
I have web access here if I try and click on this. Yep. It's not gonna let me click on that. Nope. Okay.
You may have
It's not showing up.
get out.
Sorry?
You may have to.
So perhaps, we can go back and look, and I have them embedded in the resources at the end. All that to say that there is a wonderful platform system available for free on the Office of Research Integrity website. You do have to have Adobe Photoshop. So I'm actually working now with the Office of the new Vice President for Research to provide funding along with the provost so that we all can have access to Adobe Photoshop so that you can use this platform called Droplets to make sure that the images that you're putting out and you're submitting haven't been manipulated in some way, perhaps by a trainee or a staff member, to say that they're doing that, but just to protect yourself. So again, we'll try those links again if there's time. So now we've touched on fabrication, falsification. Let's talk a little bit about plagiarism. We all know what plagiarism is, right? If you plagiarize yourself, when do you most, in terms of publications, when are you most apt to plagiarize yourself? Say again? It's generally the methods section, right? If you're putting in a second or third publication of a study that you've been working on for some time, you generally know that. Well, when it was published the first time, it was copywritten by that journal. You can't cite it. But if you go word for word, you plagiarize yourself. Because that's actually owned by another journal. So you can, although, well, really, I don't think you're going to come out per se for that. Just a kind of a heads up. So again, going back to definitions from ORI and UAB, appropriation of another person's ideas, processes, results, or words without giving credit. I include the graduate student handbook statement because there have been some times where two graduate students, again, if you are going down that road where you'll have graduate students working with you, they each need to have a dissertation. If they are co-first author on paper, they will each want to use that paper in their dissertation. And if they do, then the second one who defends has plagiarized the first. Just a heads up, it's true. So there are ways around that. You can do a classic type of dissertation, which looks to be one large paper, rather than sandwiching papers together. But it can happen. Again, just a heads up to not fall in that trap. This is an interesting type of plagiarism. Have you ever heard of mosaic plagiarism? Usually it's kind of tweak a word here or there, right? Look at this now. Okay, so the one on the left, microRNAs or small non-coding RNAs that downregulate gene expression during various crucial cell processes. And then on the right, microRNAs and mRNAs, or small non-coding RNAs of 19 to 24 nucleotide, so on and so forth. And then look, it got published. 2 different places. It's plagiarism. Let me give you a personal example. Yes, I was an associate editor for a while. Like, we all review papers, right? So my area of research is looking at the impact of exercise, aerobic exercise, on asthmatic responses. Crazy topic, right? Only a few people in the world, when we started out, were looking at this. So we would all review each other's papers. I get a paper to review from a group outside the U.S., say where. And oh my goodness, I am reading my first paper on this topic. Oh my goodness. And it was this kind of, so I alerted the editor who asked me to review, and I said, this is not kosher. Well, they went back and forth, and ultimately they validated what we did, but it did get published. I was not happy with that. It happens. This is not made up. It really happens. Okay, example. Get you thinking. Is this plagiarism? 87 years ago, our ancestors established on the North American continent a new country based on freedom and aimed at the big idea that everybody is just as good as everybody else. Now we are struggling against each other in a contest of whether this country or anyone like it can survive for very long. Oh, no. We stand here where we have fought a bloody battle in an effort to convert part of this area into a sacred place for those who made the ultimate sacrifice for their country. It is a noble thing to do. Is this plagiarism or no?
Yes.
Why?
Since you asked. It reminds me of something that I cannot identify what it
Okay.
is.
Anyone else?
Is the Gettysburg Address.
Yeah. It's the Gettysburg. Great. So we can't change to that one. This is a very well-known document, right? So right, yeah, I mean that's plagiarism because it's not an independent or new idea. But sometimes there are tough ways to say the same thing. How many different ways can you say that a frog is green? Is that plagiarism, or is that a well-known and accepted fact? What do you think? It's a tough line, right? I mean, how many different ways can you say something that's really well-known? Just to be aware.
Okay, if you cited the previous one,
Yeah.
because would that still be plagiarism? Because there was a lot of paraphrasing I could see.
Then that would be okay. As Abraham Lincoln said in his Gettysburg Address, blah, 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 right? Because you have given credit to who came up with that idea first. Right, so when in doubt, cite. Say you're paraphrasing someone's previous work to be sure that credit is given. So one way to try and break that habit, again, you've read all different kinds of papers and you sit down to write your paper. And you know that stuff gets stuck in there and sometimes it just comes out. And it's words that you've read before, you think it's yours, sometimes it gets all jumbled. So this is just maybe a protocol that you can think about how to read and analyze the structure and content first. Take notes on strategic points, but not verbatim. And then draft from memory a summary. Really, again, to try and protect yourself from falling into that trap. We all do it. It's not hard to do. But if you create a new habit in that way, that will help. But if you want to make sure that you haven't fallen into that trap, there are platforms out there. Are people familiar with Turnitin platform? Authenticate is kind of the Turnitin on steroids. There are fewer false positives or false negatives for Authenticate, and it is the one used by most journal editors. This too is another platform that I'm trying to get purchased and have all of us have access to, faculty, training, staff, to again just protect ourselves. It's so easy to fall into this trap. You don't want it kicked back by an editor saying, "Oh, hey, like we received this, criticism that you may have plagiarized." You don't want to go down that road. So this would be a tool that you can use hopefully to check your own work.
Do all journals use this kind of software?
Say again?
Do most journals use this kind of software?
Most nearly all of them, especially Elsevier. If you're familiar with Elsevier, they're probably the biggest publisher. But they all use the Authenticate to check it. As they do that Adobe Photoshop with droplets to check images. So how common is scientific misconduct? So what I'm trying to show here is a progression. And I do really want to show this link. So there has been a progression, if you will, maybe at least people thinking along these lines. You can see that conservatively, back now about 10 years ago, estimated 1.5 incidents per 100 per year. And of course, these are mostly anecdotal. I'm not sure how true to themselves people will be on these types of surveys. But I do want to show you case studies from the Office of Research Integrity. So you can actually go to the ORI website. Never ever want to be on this list. These are cases that have either been brought to them directly or have come to them from universities, if you will, thinking of allegations initially of misconduct. They have been investigated sometimes for years, like the Eric Coleman case that I showed you earlier. And then they're posted. Most of these people who show up on here are faculty. However, there have been trainees, postdocs, and graduate students who have been shown without a doubt to have fabricated or falsified data in a reckless manner. And sadly, UAB has one notable case, which you may be familiar with, Judy Thomas, several years back. You can go and read in excruciating detail if you want to. This case, Phil Menos was on this case, my former chair. Well over 2 years, thousands and thousands of pages of documentation, lawyers involved, way too many people involved. Long story short, this was a group who was looking at the benefits of attenuating a rejection response following transplants, a kidney transplant. And so they were working with primates and thought to be showing their new drug was preventing rejection of a transplanted kidney. So reportedly they took out both kidneys from a primate, transplanted one, administered this drug, and it was showing that the primate was doing fine, so on and so forth. Turns out they didn't take out both kidneys. They only took out one, transplanted the other. And so, yeah, the primate was doing fine because he was working off the original kidney. And when we go and look at the one that had been transplanted, it was all fine. They got caught. Whistleblower. So it's not to say it doesn't happen here. It does. But again, I wanted you to be aware that these are probably the most extreme cases, but sometimes there's a slippery slope. And to be, again, aware. Any questions? What would you think would drive people to do something like that? What would drive anybody to fabricate or falsify?
Create funding or meet deadlines.
Yeah.
Prestige.
Publication, promotion, money, grants. There's a lot of pressure out there we have to take.
This may be an obvious question or an obvious answer, but with each of those cases, is there gross negligence on the part of the person being investigated? Meaning, for instance, was that research design such that both kidneys would be removed and then there was a gross mismanagement of the protocol?
It could be all of the above. My impression is it was a lot of she didn't check closely enough.
Okay.
Perhaps there was a miscommunication between faculty, trainees, and staff as to what exactly that protocol was, and maybe not followed. And oh my gosh, you get down the road and you discover they didn't do it correctly.
And the PI gets all the punishment basically in that situation.
At the end of the day, it's the responsibility of the PI. For the safety, as you heard prior with Cari, Oliver, for the oversight, the management, it all lands. So yeah, there's a lot of pressure. There's a lot of.
But the other people who work for them can't be paid for a long time because they're people who get in this situation can't have an NIH grant for years or ever sometimes.
Right.
So
It trickles down.
Yes, it trickles
Yeah.
down.
Yeah, the thing too, I mean, a trainee perhaps that had his or her name on that publication that involved for this, now everything gets retracted. They have a blemish perhaps on their record, or certainly a shadow. They need to do. So the ripples are a lot.
So if, for instance, in this case, halfway through or towards the end when you're starting to analyze the data, you trusted these individuals to collect really good data and do really good studies, you realize the data is in this FFP and just basically very null.
Yep.
can you then submit to the IRB and say, you know, this data is bunk because of X, Y, Z. I apologize, and you know, report back to the NIH and say, you know, we have made gross.
We dropped the ball. Yep.
Okay.
Yep. And that's why I was throwing myself out as an example with that student. I didn't look at the data books closely enough, so I didn't go down that road, but I could have, had I not, you know, stopped at one point. Because you get busy. You know, you teach classes and writing grants and all this other stuff, not to mention raising 2 little kids this time. Life happens. You go, oh, crap. Yeah. And that's why we're trying to get the word out too, not only for faculty and trainees, but staff as well. They play such a critical role in definitely the day-to-day handling of data. You know, I'm throwing out this word data. What word data? How do you define data? What's data? The Holy Grail, I know, but what's data?
Information used to answer questions.
Okay, so we talked about raw data, so the numbers that you collect. What else? That's just a small piece.
Like just notes in the notebook, how did you perform experiment and what did you, how did you design?
The protocol.
Yeah.
That's data. The protocol of how you did the experiment, and then the statistics, how you analyzed it. That's data. What else?
Exactly what reagents you used.
Reagents that are used. What else?
The readout from, you said the raw data.
So the raw data, right? The samples. The samples are data. All of it's data. It has to be managed. So we're so focused on the numbers, right? And the results. But how you get to those results, those are all pieces of data too that have to be managed and cataloged and refined, techniques. That's all part of the puzzle to be aware of.
It's a sort of interesting experience to go to a large pharmaceutical company that does research and to see how they handle their notebooks. And basically, at the end of every day, a person signs their notebook, and that can't be changed anymore.
Signs, dates it, stamps it, and yes, GLP, good lab practices for industry, very rigorous and to the point. So I talk, disclaimer, I talk a lot about my kids and my family when I get times. My husband, also a faculty member here, we were recruited 20 years ago. He had a research program here for 10 years. And then one day he says, you know what, honey, I want to start a company. I'm like, okay. Leaves tenure, 2R1 on the table, and start the company. And he didn't understand GLP. He does now, because he has investors who are throwing money at him. He's out, you know, meeting with people at Philly now. But they are incredibly strict about time because it goes toward patents and all that. And those are really procedures that should be adopted here because it's absolutely critical, especially when you're working with clinical studies. You can't walk in mice and cells are fine. People, though, you know, just a bios, have to be soaked to the letter. So to think about all of those pieces of data, I want to briefly mention rigor and reproducibility. This is sort of the new mantra for the NIH. Has anyone heard all the discussion and talk about it? So, and this kind of gets confused sometimes with this conduct. And it's really caught the attention of the public with regard to repeating studies. So you put out a publication, and then someone picks up this thread and tries to repeat your work, and they can't do it. And now the public's thinking, oh, well, everyone's wrong, right? And this really was brought to the front by the drug Ambien. Are you familiar with Ambien? Sleeping drug. Well, when that was first brought to market, a lot of the studies that showed its efficacy were only performed in men. So then when it was open to the market and also prescribed to women, women had a very different outcome. You've heard of the sleep driving and the sleepwalking. Those studies were never performed in women. And it turned out that women actually went to have a lifestyle drop much more slowly. So even though they were getting the same dosing prescription, if you will, they were building up toxin levels and sleep driving. So that really hit, kind of a nail on the head, and really drove a lot of this conversation that there has to be reproducibility, say, in both genders. That's just one example. That's really blossomed now to really look more closely at the differences that people see when they can't reproduce results. A lot of those things we talk about that are data, the reagents, how samples are scored, how they are treated perhaps, different serum, different media, lots of media can have differences with regard to outcomes. So there's a huge initiative now in trying to hit this home with regard to make sure that antibody that you purchase from wherever, not the same occurrence, I hope, really detects what it's supposed to detect. That costs a lot of money. You are so focused on doing the experiment, and now you have to go back and check the reagents as well. But I just want to highlight this topic. I know that the CTS will look, again, at the end of real time, has a wonderful webpage on rigor reproducibility and how to address all these different areas of the proposed research, authentication of reagents and resources, consideration of biological variables like gender, and again, rigorous experimental design. And Dave Redden, whom I'm sure you know, is working on a really cool platform. It's a kind of a competition platform where you read a paper and have to answer so many questions with regard to rigor reproducibility. But there is, again, a lot of attention and emphasis on this topic right now that we need to be aware of. So what is not scientific research? Honest error. We're human. People make mistakes. You may transpose numbers. A difference of opinion. Difference in interpretation. That's not misconduct. That's science. We all want to argue, right? Science. That's the nature of the game. But that's not misconduct. Sometimes that gets ignored. So in the last few minutes, I want to maybe plow through some kind of practice questions, one or two of them we'll have time for, to kind of get you in that sentiment of what is misconduct, what is not, as a case study. So this is a trolley problem. All right. A trolley is running out of control down a track. In its path are 5 people who have been tied to the track by, we'll call a mad scientist. Fortunately, you flip a switch, which will lead the trolley down a different track to safety, but there's a single person on that other track. What do you do? Do you do anything?
Switch.
Do you flip the switch? You would. Why?
There's less on the other side.
Well, what do you know about those 5 people that are tied to A?
I don't know much.
Do you know that they're alive?
I don't know.
Right. No. Is there anyone in the trolley? What do you do?
Do we have enough time to get
No, you don't. You got to decide. You see this thing careening down the track. What do you do?
Make assumptions and make the best decision.
Or do you do any? I mean, just whether you do something or not, you're either changing the course of the trolley or deciding not to have an impact. Okay, so next one. Trolley number 2. Another trolley, that company, running out of control down another track. In its path are 5 people who have been tied to a track by a different mad scientist. You're on a bridge under the trolley, which will pass. You can stop it by dropping a heavy weight in front of it. As it happens, there's a very bad man next to you. Your only way to stop the trolley is to push him over the bridge onto the track, killing him to save 5. Should you proceed?
Jump yourself.
Jump yourself.
But you won't.
What do you do?
They're
Or
not
do you do nothing?
Oh, that's tough.
That's tough.
Yeah.
Okay, oh, but wait.
I would ask the fat person to sacrifice himself. And he may. Very
He may
poor
take
health.
you with him.
Yeah, I mean, that's okay. With his consent.
You and not
What's consent?
having
I will say,
enough.
let's jump together.
Let's
Not
jump
having
together.
enough. So once you kill yourself and the other 5 kilos.
So,
Let's keep going. Medical problem number 1. You're a doctor in an emergency room and 6 patients come to you. They've been in a terrible wreck. Probably one of those trolleys, I'm thinking, right? 5 of them sustained moderate injuries and 1 of them is severely injured. You can spend all day caring for the one severely injured victim, but in that time the other 5 would die. Or you can look after the 5 and restore them to health, but in that time the one severely injured person would die. What do you do? This is more mine.
Moderate sounds like they're stable, so.
Say again?
So moderate injury sounds like they're sort of stable, so fix the severe.
Okay. Okay, last one. You're a transplant surgeon. You have 5 patients, each in desperate need of a transplant. 1 needs a heart, lung, kidney, so forth. You've had no organ donors, and you're about to see these patients die. And then, it occurs to you, in the next room, healthy guy came in for a checkup, probably was running that trolley, I don't know. He's taking a nap, going really quiet. Harvest each of the organs, he would die, but you'd save the other 5.
oh my God.
What do you think? Okay, so where are we getting at, right? So this is all moral reasoning. So in both number 1s, where you would change the track or the trolley going down the track, or essentially the triage, right? The right thing depends on the consequences that result from your action or inaction. So where is morality? It's located in the consequences, the state of the world that will result from what you do. Versus more the categorical decision, and this is where you would either push that fat guy over the bridge or sneak into the waiting room. The right thing depends on the intrinsic quality of the act itself. Morality is located in the absolute. So all that to say, there's a lot of ethical reasoning that goes into the decision making of how you do your science. How does what you do impact others for the greater good? I want to finish up with if misconduct is reported, what happens? May you never have to know this. Certainly, if you were to see something that looks a little fishy, or perhaps if someone else has a concern, this is certainly the list of people that you can turn to. A supervisor, chair, dean, so forth. But I wanted to also point out the Research Integrity Officer, also known as the RIO. Here it's Dr. Pam Bunellis, and she is the one that really adjudicates all of these types of concerns, the whistleblowing complaints of misconduct. There's also an ethics misconduct hotline that anyone can report to. This is a hotline that actually routes through a third party, so you are actually given a case number if you were to call with a concern. You have to keep that case number in order to access any information going further. But it does route through a third party to preserve the anonymity of the complaint. Again, just a matter of sourcing here. So if there is an allegation that does come down, as I mentioned, Dr. Bunellis, the RIO, starts to adjudicate the process. I've sat on one of these assessment committees. It is gut-wrenching. It's generally about someone you know, a colleague, that there has been a complaint made. And in essence, there is, again, first an assessment phase where this complaint is kind of sliced and diced, unpacked, if you will. You start to go through all of the notebooks, the hard drives, the emails, all of that are considered data in this regard. And basically our job was to see if there was smoke, never mind the fire. But if there was enough smoke to warrant a further or deeper inquiry, then it would then move to the next phase. And that's what we do. If it does move to that next phase, there's a full-blown investigation where people are interviewed, there's evidence taken, there are lawyers at the table, and it can get quite sticky. And ultimately, there's a final report made. If that person is found guilty and has had certainly federal funding of some sort, the relevant authorities are notified, and any monies are retracted if they're here now or paid back from the institution. UAB would have to pay the money back, for example. ORI may bar any future federal funding or funding for a time for this particular person. And again, as we mentioned, there are fines and potential jail time. What if you're not found guilty? An allegation is made, go through this whole process, and it turns out it was honest error, for example. Then the university, as well as the ORI, is responsible for restoring the reputation, remediation if necessary. Tough to do though, yes? And once the word gets out, it's kind of hard to pull that back. But they do make every effort to sponge them. Just one final note. Yeah.
An important thing though is that the initial assessment phases are really very confidential. And
They are.
So
They are.
it can't always be controlled, but there's a stern effort made to try to protect people, at least until there's clear evidence that there was one happening.
In severe cases though, you kind of see the team go in and they start taking computers and closing the lab. And then, it kind of trickles down. Yeah.
I have experience when we publish one paper and some of the data, because it's not expert of analyzing the data, it's just a misinterpretation. But the paper is published and then later we found that problem and then we tracked it, the paper. So in that case, what the university can deal with that?
But that's not misconduct. If it is honest error, perhaps a misrepresentation.
It's honest data, but just interpretations not
Right.
right.
So definitely you can address that, meet it head on, and say, we found this, we took responsibility, we retract it, and now we're going to publish a correction. Right. No, you meet it head on. You don't want to do that. Just a final note to say, this is the great Albert Einstein. The truth implies that it's a duty, and it's a responsibility, and the greatest thing we have is the trust with each other, with our patients, with our subjects, and certainly with the public. They're going to keep funding coming, we hope. A lot of concerned people right now at the NIH as to how things are going to go. And I'll just end with a little anecdote. A friend of mine was a scientist, was in the airport and found herself sitting next to Senator Shelby and started asking him, this was prior to the inauguration, after the recent election, where do you see the future of the NIH? Shelby has his name on a building here, and certainly up at Huntsville, and has been a really good protector of NIH funding. And sadly, he made the comment or the implication that, well, scientists make up data. So we have a hard fight ahead of us, and it's a responsibility to make sure that we do the best work that we can. That sentiment is out there, and that could be far-reaching. I don't want to be all doom and gloom, but to further the conversation and try to talk with the public and to share what we do in a responsible fashion. The graduate school now has something called Discoveries in the Making, where we get out into public libraries and talk about the work that's ongoing here to really keep that dialogue flowing, because we need their trust. That's important for the future. Any questions? Again, I'm going to get these slides out to you because they have so many. Oh, I was going to show you the resources. Show you the NIH ORI website. They have a wonderful webpage on rigor and transparency, as does the CCTS. So check them out, incredible amounts of information, very useful. But if you have any questions, just let me know. I have contacts here for both myself, Pam Ellis, and Joe Roberson in compliance.
So there will actually be another session on the rigor and reproducibility, specifically when we get into the biostatistics part of the course, so we can anticipate more detail about that then. This is a great introduction.
Great. Well, thank you all.
Thank you.
Take care.
Right on time. So this one I'm gonna trash. This one, should I leave this up here for Jean?
Yeah.
She, this is the one that can be sent out. I trashed the old version.